Hello, my dear student. A very good morning to all of you. In previous video, we have discussed. In previous video, we have discussed the light amplification in laser and the gain. There is the amplification and gain. In this video, we have discussed the threshold condition. Discuss the threshold condition. What is mean by threshold value? What is mean by threshold? The threshold value, that is the meaning of that threshold value is that value the oscillation will be happen. This oscillation will be happen. Then we have to discuss the condition, threshold condition. Before the threshold condition, before the study of threshold condition, we have discussed the one point, that is the optical resonator. That is the optical resonator. Optical resonator, or it is simply known as a resonator cavity. This is simply known as a resonator cavity. This is the block diagram of that optical resonator. Is these are the active medium. We know active medium. In previous video we have discussed. This is the active medium, and that active medium in between that two mirror M1, M2, and that medium, that M1 is the 100% reflecting, and that mirror M2 is that is the partially reflecting. Partially reflecting, that is the 90%. This is the 100%, that is the perfectly reflecting, and this is the partially reflecting, that is the 90%. In that mirror, some photons are incident on that reflecting mirror. It is 100% is reflect back, and this is the 90% reflect back, and 10% will be transmitted. 10% will be transmitted, and that is the pump light, that is the pumping. What is mean by pumping? Pumping, that means to provide energy. This is a simply block diagram of that optical resonator. This is the optical resonator. Then the working of that resonator. This is the active medium. Then that is the working diagram. These are the two mirrors. And that is the active medium. That is the N2. This is the energy state E2. This is the N1, and this is the energy state T1. And these are the pumping. That means to provide energy or to incident the energy on that atom. Initially, in ground state, that is the E1 is the ground state. Initially, the more atoms or electrons in that the ground state. Then we are pumping of that active medium. That means we provide the energy of that atoms or that active medium. Then that atoms goes on that excited. That means this atom will be excited and jumps into that excited state. That means that is the number of atoms in that condition. The number of atoms is more than where that is the excited state. That is the population N2 is greater than the population of N2. This is the population inversion. This term is known as a population inversion. Population inversion is that is the number of atoms is greater than the number of atoms is greater than number of atom in excited state is greater than the number of atom in a ground state. That is the population inversion term. Where that atoms will be or that active medium will be pumping. Pumping means to provide energy, and that atom that absorb energy and jumps into the excited state. Then the number of atoms in excited state are more than that number of atom in a ground state. But these atoms do not stay more than the 10 raised to minus 8 seconds, and it will come back to the ground state. But this excited atom will emit a photon, and that energy is a h mu. That energy is the h mu, and that is h mu is the that energy difference between that two state, that is the excited state E2 minus E1. E2 minus E1. That excited atom do not stay in the 10 raised to minus more than the 10 raised to minus 8 second, then that atom is come back to the ground state, but it will release a one photon. It release a one photon. Okay, and that photon is a force or trigger of that remaining excited atom. That photon a trigger or force that remaining excited atom, that atoms that jumps into that excited state into come back to that lower state, that photon, then one photon will be come back to that, and that will release energy. Then this process is that in previous video we have discussed, that process is a stimulated emission. That process is a stimulated emission. That means this is the chain for the stimulated emission. That photon, that emitted photon will force the another excited atom, and that is the come back to the ground state, and it will be the emitted photon. That will be the chain. Suppose that one photon will be emitted a 2 photon, then another photon will be emitted a 2, 4, 6, another. That is the chain of that stimulated emission. Chain of that stimulated emission, and that photon are in same phase. That emitted photon are in same phase. In previous video we have discussed that point. We have discussed that point. Then in that optical resonator, this is the action of that active medium. We are pumping that active medium, then this action, that is a spontaneous emission and stimulated emission. Spontaneous emission and stimulated emission. That is the chain of that stimulated emission. Then in that diagram, the photons will be emitted, and this photon is a same phase. That photon is incident on that partially reflecting mirror, then it comes back, that is after reflection, that enters into that active medium. Then the active medium, then that photon is again force that excited atom, and that atom is come back to the ground state. That photon is reflecting back and enters into that active medium, then photon against the force or trigger or that of that excited atom, that we can goes back to the ground state. That means number of photons will be come back to that ground state, and that is the number of photons will be that photon is the release energy, that is the emitted photon, number of photons, and that active enters into that active medium, and that photons will be again force or trigger of that excited atom. Then and this goes through that incident on that mirror M1. Then after reflection, this is the 100% reflecting, and that after reflection this come back to the active medium. This is the process will be continuously, and that is the multiple reflection. This incident on that M1, after reflection it enters into active medium, and again it incident on a mirror M1, then after reflection it enters into the active medium. This is the multiple reflection. Of that photons, that is the photons, multiple reflection of that photons, and because of that multiple reflection, that is the we amplified the light. In previous video we have discussed that is the amplification of light. But in that partially reflecting plate, the some part of or 10% light will be transmitted. And this is the laser output. This is the some functions, or this is the some function of that optical resonator. That is the optical resonator. Because of that two mirror, that is the multiple reflection, and of that is that the multiple reflection, that is the increasing the multiple reflection. That's why that multiple reflection, that lights will be amplified. But in that mirror M2, that is the 10% transmitted. That's why that is the 10% light will be transmitted, and that is the partially transmitted through that transmitted component, that is the loss of energy, that transmitted component, that is the loss of energy from the that resonator, from that the resonator, and this is the simply is denoted by alpha s. Alpha s is the loss of that energy through that transmitted component, that is transmission, because 10% light will be transmitted. This is the simply function of the optical resonator. This is a simply function of the optical resonator, and in that diagram we are the function of spontaneous emission, stimulated. What is meant by spontaneous emission, stimulated emission? We discussed the previous video. Then we start our point is a threshold condition. Point is a threshold condition. What do you mean by threshold value? That value, the value of that threshold, that will be the oscillation will be happen. Oscillation will be happen. The threshold value is that the oscillation will be happen. This value is the threshold value. Then threshold condition. Simply we discuss the optical resonator. Let us assume the laser medium. Let us assume the laser medium laser medium, and that the space between, let us assume the laser medium fills the laser medium, that means active medium, fills the space between the two mirrors, fills the space between the two mirrors M1 and M2, which have that is the reflectivities, or this is also known as a reflection coefficient. This is also known as a reflectivities. It is R1 and R2, and this is also known as a reflection coefficient. This is also known as a reflection coefficient, R1 and R2 respectively. Then this mirror, that two mirror, we have discussed that two mirror, and this is the separation distance between that two mirrors is a L, capital L. Then let the mirror be separated by distance L, capital L. That means this mirror M1, this mirror M2, and this is the active medium. This is the active medium. This mirror M will be perfectly reflector, and this is the partially reflector, and these are the pumping. The pumping or that provide a energy, or that mirror M1 and M2 is separated by distance L. Then initially the intensity of light beam, initially intensity of light beam, that is the incident light beam, is intensity be I0. Initially intensity will be I0 at that M1, Then in traveling from mirror M2 to M1, that light traveling from mirror M2 to M1, that intensity goes on increasing. Why? Because amplification. In previous video we discussed the amplification. In amplification the intensity will be increases. Then light traveling from mirror M1 to M2, the beam intensity, that intensity will be increases from I2 to IL, and L is the distance between that two mirror. The intensity will be increases, which is given by the equation I of L is equal to I naught. It is initial intensity e raised to gamma minus alpha s into L, equation number 1. Okay, and this alpha s, where alpha s is, this is a loss. This is a losses mainly due to the transmission, either scattering, either diffraction of that within the medium, either transmission, either scattering, either diffraction. This is the losses within the transmission, scattering or diffraction within the medium. Then after reflection of M2, this light is incident on that M2, and this M2 will be incident on that M2, this light will be after reflect back, and that after reflection of M2 the beam intensity will be that R2 I0 e raised to gamma minus alpha s into L. This the after reflection of that M2, this is the partially reflected, and that light beam is reflected back, and after reflection at M2 the beam intensity will be R2 I0 e raised to gamma minus alpha s into L, and complete the trip. This start from that point, that after reflection, and goes to that again incident on that mirror M1, that is the complete round trip of the final intensity, and that is the I L plus L, that is the 2L, I 2L is equal to R1 R2 e raised to gamma minus alpha s into 2L, equation number 2. This is the intensity is the complete round trip. After reflection, that is the R2 I0 e raised to gamma minus alpha s n, and again reflection and goes on that again mirror M1, that is a complete trip, complete round trip. This point to this and this to this complete round trip, that is the intensity I2L R1 R2 e raised to gamma minus alpha s into 2L. Then the amplification is obtained. During the round trip, is, that is the G is equal to I2L divided by I naught. That is the initial intensity, and that is the amplified intensity. That amplification is obtained during the round trip, that is the gain is equal to, that is the amplified intensity, that is ratio of amplified intensity to the initial intensity, and I2L is the equation number 2 are the R1 R2 I naught e raised to gamma minus alpha s into 2L divided by I naught. I naught get cancelled, and that is G is equal to R1 R2 e raised to gamma minus alpha s to L. That product R1 and R2, that is the reflectivity, or that is the reflection coefficient, that is the R1 and R2. Okay, and that is the R1 and R2. This is the represent the, also that R1 and R2, this represent the losses of the mirrors. Which losses of the mirrors? Alpha s is the loss of due to the transmission, diffraction or scattering. But this R1 and R2, this is the losses of the mirror. The loss are balanced by the gain, and that loss is balanced by the gain when that gain is greater than or equal to 1. Condition are that gain is greater than or equal to 1. But at least that condition, that G is the R1 R2 e raised to gamma minus alpha s 2L is greater than or equal to 1. Then this losses will be goes transformed of that side, and remaining side e raised to gamma minus alpha s 2L is greater than or equal to 1 divided by R1 upon R2. Then next step, taking log on both sides, we get the remaining term 2L gamma minus alpha s is greater than or equal to, this is transform from that numerator, that is the R1 R2 raised to minus 1, and taking log, that is the minus ln R1 upon R2, then this 2L is transformed on that side, then remaining term are therefore the gamma minus alpha s is greater than or equal to minus 1 upon 2L ln of R1 upon R2, ln of R1 upon R2. Then gamma, this minus alpha is transform of that side, gamma is greater than or equal to alpha s, this minus transform, this will be the plus, minus 1 upon 2L ln of R1 upon R2. Then therefore gamma is greater than or equal to that alpha s, this ln, and this is the reciprocal of that R1 and R2. This will be the sign will be changed and that will be the plus. Then alpha s plus 1 upon 2L ln of 1 upon R1 upon R2, equation number 3. And that equation 3 is known as condition for lasing. That equation 3 is known as a condition for lasing. And this condition is used to determine the threshold value. Of pumping energy for lasing action, because in lasing action the pumping energy will be required, and that condition used to determine the threshold value. Threshold value means that value the oscillation will be happen, and this condition is used to determine the threshold value of pumping energy is necessary for the lasing action. And that gamma is the amplification. Of laser will be depend on the how hard laser medium is pumped. This gamma, the amplification of the laser will be dependent on how the laser medium is pumped. That means how the laser medium will be pumped. As the pump power is slowly increased, that means pumping power, the incident energy will be slowly increased. The value of gamma th, called as threshold value. Gamma is called as a threshold value. This we write as the pump power is slowly increased. Pump power means incident energy will be slowly increased. The value of gamma is called as a threshold value will be reached and the laser start oscillating. Yes, as the pump power is slowly increased, that means incident energy is slowly increased, then gamma called as a threshold value will be reached and laser start oscillating, and this threshold value gamma is given by alpha s plus 1 upon 2L ln 1 upon R1 R2. This is equation number 4. Gamma, then the threshold value gamma is equal to alpha s plus 1 upon 2L ln 1 upon R1 upon R2 for the laser. In that condition, that for the laser, in that value for the laser will be oscillate. And equation 4 is known as a threshold condition. Equation 4 is known as a threshold condition for lasing. This is the threshold condition.